Okay, this is the introduction to quadratic functions, and we're going to graph quadratic functions in vertex form. Number one, f of x equals ax squared plus bx plus c is the standard or general form of a quadratic equation. The graph of a quadratic function is a U-shaped graph, so it's called a parabola, and it's going to look either like a U that opens up or a U that opens down. If a is greater than 0, that means this number here, if it's positive, then the parabola opens up. And if this number here is less than 0 or negative, the parabola opens down. So this one would have a positive a value, and this one would have a negative a value. The vertex is the maximum of a down opening or downward parabola, and it's the minimum of an upward opening parabola. So if I say to find the maximum of a parabola, I mean find the vertex. If I say find the minimum of a parabola, I mean find the vertex. The graph is also symmetrical with any vertical line drawn through the vertex called the axis of symmetry. So parabolas are symmetrical, and you can use that to help you get extra points. So if I have a parabola and have a vertex here, we'll call it HK, then the axis of symmetry is this line that you can draw right through the vertex that cuts this parabola in half, and it's an equation of a line, so it's always going to be x equals h. F of x equals a times x minus h quantity squared is a big deal. This is called the transformation form. Also, I typically call it vertex form, because when you have a quadratic in this form, so you can manipulate equations or functions by adding, subtracting, dividing, as long as what you do on one side you do the other, or what you do on one side you take back. So I can rearrange, and I can mess around with the standard form and put it into what we call vertex form. And just, you have to memorize vertex form. It may or may not have a number here. It might be an understood 1, and then parentheses x minus, it might be a positive number, x minus 2, or it might be a negative number, which would then show up as x plus 2, quantity squared. So you're looking for that square. You have to be on the lookout for x squared. That's what makes it quadratic, and then plus k. And if you remember from transformations, you know what each of these things does. This h moves it right or left, h units. This k moves it up or down, k units, and this a will vertically stretch, shrink, or even flip it if it's negative. So we're going to look a lot at the vertex form, and so the first one we have is f of x equals 2 times x minus 3 quantity squared minus 5. So before we graph, we should know the direction of the opening, and we do that by looking at the a value. The a value is positive 2, so this opens up. Alright, so I'm going to sketch it without graphing it. I know it's going to be an upward shaped U. What would the vertex be? Well, the parent function, y equals x squared, has a vertex of 0, 0. So if you translate this to the right 3 and down 5 from the origin, that means that the vertex is going to be 3, negative 5. So when a quadratic is in this transformation form, the vertex is the h the x-coordinate is right here, h, and it's not negative 3 because the formula is x minus. Remember, you have to do the opposite of what you see. So you go right 3, and then this negative 5 is the y-coordinate because you go down 5. So the vertex just pops right out. Okay, now I like to graph it so I don't mess up this question here. Is the y-coordinate of the vertex a maximum value or a minimum value? Well, if you look here, this is the lowest point on the graph. So this negative 5 is the lowest y-coordinate. So this is a minimum. And then the axis of symmetry. Again, if you draw a vertical line through that vertex, you get this vertical line x equals 3. Next, we have f of x equals negative 1/3 x plus 2 quantity squared plus 4. So this a value is negative, so it has a direction of opening that's down, and I like to sketch it because I don't want to make a mistake, and I'm a visual learner. And the vertex, think about transformation form, think about the formula, is x minus h. So this is really x minus a negative 2 quantity squared. So the vertex isn't 2, it's negative 2. It's the opposite of what you see when it's in there with the x. And then it got moved up 4. So we know the vertex is negative 2, 4 because it's moving the parent function left 2 and up 4. That's where the vertex comes from. Is the y-coordinate of the vertex a maximum or minimum value? Is that 4 the highest of all the y-coordinates? Yes, it is. So that is a maximum. 4 is a maximum value. And then the axis symmetry, again, you just draw a vertical line through that. And so that equation is x equal negative 2. And that helps you with points. If you can find a point over here, which I'm not going to do right now, then you know that you can find another point over here. It's easy to find because of the axis of symmetry. We'll talk more about that later. Let's get me visible here. Okay, so this is a couple of examples of just graphing. And when you're in vertex form, it's actually pretty easy to graph, but it takes a little bit of practice. So first thing you want to do is you want to identify the vertex. Okay, so we have 2 and then a binomial square, that's quadratic, and this minus 5 moved the vertex to the right 5 and it moved the vertex down 7. This 2 is going to cause a vertical stretch because it's being multiplied to the outside of the function. Let me go ahead and write down the parent function. That is my parent function. We have a minus 5 that got scooched in there with the x. We have a minus 7 that got subtracted, so that's why it went right 5 down 7. And then this 2 is out front, and it's causing a vertical stretch by a factor of 2. Okay, the axis of symmetry we'll go ahead and write as x equals 5. And then let's graph it, and I'll show you the trick to graphing it. So what I'm going to do is I'm going to graph this parent function. And I'm not going to need to do it every time, but we really want to think about it at first. So the parent function has ordered pairs 0, 0. When you put 1 in, you square it, you get 1. When you put 2 in, you square it, you get 4. When you put 3 in, you square it, and you get 9. Okay, so 1, 1, 2, 4, 3, 9. But also, when you put negative 1 in there, when you square it, you get 1. And when you put negative 2 in there and you square it, you get 4. And when you put negative 3 in there and you square it, you get 9. That's what I was talking about, the axis of symmetry. If you have a point 1, 1, then negative 1, 1 is right across from it. The axis of symmetry is right there. We have negative 2, 4 right across from 2, 4, and we have negative 3 right across, negative 3, 9 right across from 3, 9. So this is what the parent graph looks like. And I want to show you how easy it is to graph if you understand translations. So this graph of this parabola has a vertex of 5, 7. 1, 2, 3, 4, or 5, negative 7, 5. 1, 2, 3, 4, 5, 6, negative 7. Okay. Now if it wasn't for this 2, it would have the exact same shape as this graph right here. So you could not even worry about getting actual ordered pairs. You could just look at what's going on. You've got a point over 1, up 1, over 1, up 1, over 2, up 4, over 2, up 4. You could just plot these points based on the movements down here, and you would have it graphed. So it's super easy to graph a parabola if you just remember 1, 1, 2, 4, 3, 9. You can graph any parabola when a is 1. But what happens when a is 2? Well, that's easy too. Okay, so all you have to do is remember back to translations. If you have vertical stretch by 2, just multiply these movements. These aren't going to be ordered pairs down here, but they're going to be movements. So if I multiply by 2, I get 1, 2, 3, my x's. I get 0 times 2 is 0. I'm sorry, 0, 0. All right, 0, 1, 2, 3 are my movements, and I get 0 times 2 is 0. 1 times 2 is 2. 4 times 2 is 8, and 9 times 2 is 18. So this one, instead of going over 1, up 1, it's going to go over 1, up 2. And you can see the vertical stretch of 2 right there. You see it? Over 1, up 2. And then the axis of symmetry says there'll be another one right across from it. Okay? Then you would go, instead of going over 2, up 4, you would go double that and go up 8. And the axis of symmetry says there'd be one right over there. So it's all about this. You can tell what the vertical stretch is, what the a value is right there. That's what a is going to equal, and you might need that for WebAssign. All right, and then let's go ahead and finish it out. So we'll go over 1, 2, 3, up not 9 but 18. And 1's going to be right across from it. And now I can sketch that graph, and when you sketch it, be neat. You want to make sure that you don't do a V, you do a U down here. And so that's a quick way to graph a quadratic function. You just graph the vertex, and if this is a 2, from that vertex you just go over 1, up 2, over 2, up, not 4, 8, etc., etc., etc. So we have this one, f of x equals negative 1/3 x plus 1 quantity squared plus 8. That is a quadratic because the 2 there, you're on the lookout for quadratics. It's in vertex form, so the vertex is, well, the formula for vertex form is a times x minus h quantity squared plus k. And that's a plus 1, not a minus. So remember, it's the opposite of what you see in here with the x's, so that's a negative 1, 8 as your vertex. This time your a value is negative, so there's going to be a flip. And so I'll sketch that now so I can keep it in my head. Alright, and not only is there going to be a flip, I wanted to show you that, this is going to be a vertical shrink because a is less than 1. The absolute value of a is less than 1. So the axis, the vertical stretch or shrink is going to be, it's going to be a vertical shrink by 1/3. I'm taking care of the negative by flipping it, and then the shrink happens by a factor of 1/3. The axis of symmetry, remember, is just x equal negative 1. It's a vertical line through that x coordinate. Okay, and so how would I graph this? Well, let me graph the parent function again. So we have 1, 1, 2, 4, 3, 9. Use the axis of symmetry. to plot those points. Okay, and there is your parent graph. So to graph this one, it's a little harder. The first part's pretty simple. You just graph the vertex. So negative 1, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so I'm going to put some points down here. Remember our movements. 0, 0, 1, 1, 2, 4, 3, 9. I'm going to have to add some because these are movements, and to get the movements with the stretch of 1/3, because remember I'm going to go down, so I'll multiply by negative 1/3. Okay, my new movements from the vertex are not so nice. Because if I multiply 0 times 0, 0 times negative 1/3 is easy, that's 0. If I multiply this y-coordinate 1 by negative 1/3, I get negative 1/3, and that's okay to graph. If I multiply this 4 by negative 1/3, that's negative 4/3. See, that's not so nice. It's starting to be not fun to multiply. So what we want to do is we want to be clever, and we want to only use multiples of 3. See, if I go over 3 and multiply 9 by negative 1/3, that's kind of nice. So I'm going to skip on down to 6 and then square 6 and I get 36. So if I multiply 36 times negative 1/3, I get negative 12. So I would probably graph these. Okay, so it's going to be upside down, and I'm going to go over, in fact, I'm just going to graph this one. I'm going to go over 3, 1, 2, 3, and down 3, 1, 2, 3. And then use the axis of symmetry, which is right through here, left 3 and down 3. From the vertex. These are not points, I'm just going from the vertex. It's my pretend origin. And then I'm going to go over 6, 1, 2, 3, 4, 5, 6, and down negative 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then use my axis of symmetry. There. So I get this vertically shrunk graph. Now let's go back to this one because I skipped it. So if I go over 1, about negative 1/3 is about right here. And so you can see what happened is your x coordinate stayed the same, but your y coordinate was 1 and it got multiplied by 1/3. So it's vertically shrinking. Okay, let's go back to increasing and decreasing because I skipped that. Alright, so it's increasing when it's going up as you go left to right. So this increasing in interval notation, whatever the vertex is, and the vertex was 5, negative 7. So remember, don't look at the y-coordinates. It's increasing from x equals 5 to infinity. It's decreasing when it's going down from left to right, but you're talking about x-coordinates, so remember, don't get this backwards. You have to start with negative infinity all the way to 5. Negative infinity has to come before your 5. The domain, well, this quadratic doesn't have any restrictions. There's no denominator, there's no radical, there's no log, so this is all real numbers. But the range, the lowest it can get is negative 7. Now this is another part people mess up. Negative 7 is a y-coordinate. It's not a whole, so the range would be bracket negative 7 to infinity. Okay, let's look at the increasing and decreasing for this one. This time it's increasing. It's going up as you go left or right here, so that would be from negative infinity to the vertex negative 1. And it's decreasing from negative 1 to infinity. And I got, my brain gets messed up. Remember, you're talking about x coordinates, so negative 1 to the right. So negative 1 to infinity. Why are there parentheses here? Well, because technically speaking, mathematically speaking, at the vertex, there's really a slope of 0 there, that you're really neither increasing or decreasing. It's kind of like when you go over a railroad track, a bump, and you're in the car and you're anticipating, because you like that feeling, you go over a railroad track, you feel a little weightless for just a split second. That's because you've reached the vertex and you're neither going up or down, and you feel that. So that's why we don't include the vertex there. The domain would be all real numbers, and the range, okay, it's got to start from the lowest to the highest. So the range goes from negative infinity all the way up to the y-coordinate 8. All right, let's finish this up by looking at the word problem that I have here. It says the profit P in millions of dollars made from an item is a function of the number of items in thousands sold, X. It's modeled by the following function: P of X equals -3 times X minus 4 quantity squared plus 5. It's the little things. If you don't sit there and say, oh, that's my friend a quadratic in vertex form, you won't get anywhere. You have to be on the lookout for that square. And so that means it's a quadratic, and we have great news. It's in vertex form. So before we answer all of these questions, we can figure out the shape of this. Okay, so we know it's going to open upside down. I don't need a coordinate plane. I'm just going to sketch it. We know it. Actually, I'll put a coordinate plane because we have to talk about x's and y's. We know it opens upside down. We know the vertex is 4, 5. Okay, so back to functions and word problems. If you want to be successful, write a Math English dictionary, right? So our input is X, and X stands for number of items in thousands. And just the fact that we're writing this down makes our brain settle down and think about this problem. So our x-axis is number of items in thousands. Okay, so our x-coordinate right here is number of items in thousands. Our output is the profit, and the profit is in millions of dollars. Okay, so this y-axis is our profit, and it's in millions of dollars. Okay, so that's our profit, that's our y, that's our P of X. So what this is saying is that when X is 4,000, when X is 4,000 items, P of X is $5 million. So now we can answer the question, what is the maximum profit? $5 million. And how many items must be sold to achieve the maximum profit? 4,000 items. So there's not a lot of math to do. Because we had it in vertex form, we had the answer right there staring at us. It's all about understanding what x and y, or P of X, is. Now, state the interval where the profit is increasing. So now this is a real world problem. So normally parabolas go on forever and ever and ever, but you can't have negative items. So we're going to say that the profit is increasing from when you have 0 items sold to when you have 4,000 items sold. So the profit is increasing in interval notation 0 to 4, but we'll write it out from 0 items sold to 4,000 items.